Hello everybody, I'm here with an example of related to calculating principal stresses and maximum shear stress for a case of stress element which is a plane stress situation, a two-dimensional version of the stress element which is shown here in this picture. And this is exactly the same problem that I use actually to show you how to find transformation equations, and at certain angle I think I use 45 degrees just for the reason that when we use the 2 theta, 2 times 45 is 90, and then I wanted to just show you quickly how you don't even have to use your calculator. But in any case, I thought maybe we should continue with the same problem, and now we'll try to find maximum normal stresses and maximum shear stress. So what I did, I summarized the equations on this side. Remember, when I showed you the derivation by trying to maximize, we had to first find the angle, the principal angle, theta 1, which is based on this equation shown here. And then remember, theta 2 is 90 degrees from theta 1, clockwise or counterclockwise, doesn't matter. So the two planes are perpendicular to one another. And then the plane of maximum shear stress, theta sub s, is 45 degrees from the plane of maximum normal stress, principal plane. Okay, formula for calculating the two principal stresses are sigma 1 and sigma 2 is the average stress here plus something that will later on happens to be the radius of the Mohr circle, right, plus this radical term. And actually the maximum, so-called maximum in-plane shear stress is equal to also the second term of this equation here, this term, which happens to be the radius actually of the Mohr circle. So the maximum, the sigma 1, you use the positive here, and sigma 2, you go with the negative here. Okay. Also note that one way we can check our answer is that the sum of two normal stresses in two perpendicular planes, like x and y are what? Perpendicular to one another, right? And 1 and 2 are also perpendicular to one another. See, they're 90 degrees apart. That sum must be what? Equal to one another, right? And we can check that in a minute. Okay, so here's our stress element right here, and we're going to use this stress element to find what? We want to find the principal stresses and maximum shear stress, and show these stresses acting on the element, which I have it on the next page. Okay, so the first thing you want to do is identify what your stresses are on the element. So you can see that sigma x is in tension, that's positive 50 megapascal. Sigma y is in compression, so that would be negative 10. And this tau xy, we talked about this earlier, guys. If shear stress is pointing up on the right hand side of this element, that's a positive shear stress. And actually I showed you the sign convention before, how if this is a positive plane and this is in the positive direction, remember those subscripts, they refer to the first subscript refers to the plane and the second subscript refers to the direction. So positive times positive becomes actually positive. Okay, so that's a positive shear stress. So just go ahead and plug into this equation right here. Sigma x plus sigma y, and then sigma x minus sigma y over 2 the plus squared plus tau xy squared. So average stress actually happens to be 20. That's your average stress. Plus and minus. The radical term becomes 50. This later on you'll see actually this is the radius of that circle. Okay? So if you go with the with the positive, you get a 70 megapascal, 20 plus 50, right? And if you go with the negative, 20 minus 50 is negative 30. So this is your sigma 1 and this is your sigma 2. Also, let's calculate at what planes these stresses happen. So let's go ahead and use this equation right here and just plug in. So we have to find inverse tan of 4 over 3, so we get 40 over 30 or 4/3. That's roughly about 53 degrees. 2 theta 1, remember that's 2 theta 1. So half of it would be about 26 and a half. So theta 1, so this stress happens at 26 and a half positive. That means you have to look at a plane that is in 26.5 degrees counterclockwise to your initial plane, to this plane right here. So you have to go 26.5 degrees counterclockwise to that to get to that plane. And then if you add 90 degrees to that, you get the second plane. Remember, theta sub s is what? Theta sub s is 45 degrees plus or minus, so that's 71.5 degrees. Let me show you these stresses. Remember, sigma 1 was 70 and sigma 2 was negative 30 and tau max was 50. And here we go. So this is our initial stress element, guys. What I did, I basically look at a plane 26.5 degrees from here, right? So that would be this guy now here, right? So right there I put the 70, right? And then on 90 degrees to that. So this is the 26.5, right? And this line is your reference. So this would be what, the 116.5 degrees. That would be theta sub 2. Okay, and then 45 degrees to this plane, this one, it's theta sub s that I showed you here, and that was the 71.5 degrees. Okay, so remember, on the plane of principal stresses, there are no shear stresses acting here. Okay, maximum shear stress will happen at this theta sub s. So I continued with that over here, and look, I put my maximum shear stress 50. It would be the same on all four faces. And then I showed you actually in the earlier video that there is a normal stress here, and that would be actually happens to be the average stress. And you can actually use the transformation equation and show that. If you want, you can prove that actually. Now, one easy way to check our answers, remember that the sum of normal stresses should remain constant on two perpendicular planes. So sigma x plus sigma y, that's what, 40. Look, 70, sigma 1, sigma 2, that's also 40. By the way, when I took this course actually many years ago, we wouldn't actually draw this element. We would actually show everything on one element. So, in other words, if you had something like this, for example, this was the principal plane, right? And then we had this other plane. Basically, I'm drawing this part, this triangle here. See this one? Just half of it. So half of it would have been good enough. So look, I'm going to show you everything on this. 70 here, that's this guy. 30 here, that's sigma 2. And then maximum shear stress right here. See that? That's the 50 that you see here, right? And then the average stress would go here, 20. And then you could tell that everything that you want to know about this. So it's 45 degrees to this plane, 90 degrees to this plane, right? And so on. Okay. The next topic we're going to talk about, guys, would be Mohr circle, which will, I'm not sure if I'm going to have that lecture for this week. I'm going to leave it for the following week. So I'll let you know, and I'm going to actually send you guys an email, and we'll, you know, in addition to all the videos you're going to see, we're going to have also a PowerPoint presentation coming up on this material. Okay, as always, thank you for watching and listening.